Let's go ahead and continue our properties of derivatives on calculus. So we've previously learned about 5 rules that allows us to solve some simple derivatives in calculus. Let's continue that. Rule number 6 consists of a rather simple rule as well. So if you're taking the square root of any function, so if you're taking the square root of a function u, then in order to find the derivative of this square root, you can simply say y prime is equal to u prime, basically the derivative of that function, divided by 2 times radical u. So basically that is the derivation of such a problem. So let's say, for example, you have y equals to the square root of 3x. So what you're going to get is y prime equals to, first you take derivative of whatever's inside the bracket, so derivative of 3x is going to be 3, and then you divide it by the simply 2 multiplied by whatever your original function was, so 2 times the square root of 3x. Let's go ahead and take a look at the next rule. We can call that rule number 7. Let's say you're taking the derivative of y equals to the square root of a function that is raised to the power, and there's also a root of any other, for example, power. It could be like 3, it could be 4, so it's not necessarily 2. In this scenario, in order to take the derivative, y prime is simply going to be m over n. So basically whatever the power on the inside is divided by the power on the outside, multiplied by the derivative of the function, multiplied by the function, raised to 1 less than its original power. So let's go ahead and take a look at an example based on this. So for example, you can have something like y equals to the cube root of x squared plus 3 raised to the power of 2. So here, y prime is simply going to be m over n, so it's going to be 2 over 3 multiplied by the derivation of the inside, so whatever u is, which is x squared plus 3 in the scenario. The derivation of x squared plus 3 in the scenario is going to be simply 2x. And then you can multiply that by x squared plus 3 raised to the power of 2 over 3 minus 1. So the power of your u is simply going to be 2 over 3 minus 1, which is essentially negative 1 over 3. All right, let's go ahead and take a look at our next rule. Now before I do, let's take a look at a harder example. Let's say you're given y is equal to 4 divided by the cube root of x squared minus 3x raised to the power of 7. So in such a scenario, you just kind of have to make things nicer first. So you kind of have to bring whatever is down there up. So you kind of have to use the rules of division of the same bases and things of that nature. And basically by bringing that cube root up, you're just going to have a function that looks like this. So y looks like 4 multiplied by essentially x squared minus 3x raised to the power of negative 7 over 3. So basically, if you were kind of simplifying the function below there, you can write it as y equals to 4 over x squared minus 3x raised to the power of 7 over 3. And if you were to bring this up, then you would get the negative version, which is what I've written right here. So how do you take the derivative of this then? Well, y prime is simply going to be 4 multiplied by, let's go ahead and I'll show you the rule. So m over n, so negative 7 over 3 multiplied by 4, multiplied by the derivation of u, which is this part. So it's going to be 2x minus 3, multiplied by x squared minus 3x raised to the power of negative 7 over 3 minus 1. After that, all you have to do is to simplify the numbers. So y prime is simply going to be negative 28 over 3 multiplied by 2x minus 3 multiplied by x squared minus 3x raised to the power of negative 10 over 3. And that's it. That'll be your function. You can even write this in a more simplified form. Y prime equals to negative 28 times 2x minus 3 divided by 3 multiplied by x squared minus 3x raised to the power of positive 10 over 3. Because this is a negative power, and if you were to write it as a reciprocal, it would become positive. You can even change that 10 over 3 to a cube root of that same function with a power of 10. Let's go ahead and take a look at our next rule now. Rule number 8. So in rule number 8, let's say we're given a function like that three functions, or like sometimes even two functions that are multiplied with each other. We call this the product rule. And this is actually a very simple rule once you get around it. So if you have a couple of functions like u times v times w, in order to take the derivative of such a scenario, you just kind of have to take the derivative of each of those simple functions and then multiply them by the normal version of the two other functions. So you multiply u prime by v by w, and then v prime by u by w, and then w prime times u times v. So, and what that means is you take the derivative of each of the functions once, and then you multiply them by the normal form of the other two functions. Now, we can have something that's a kind of simpler version of this. For example, we can have y equals to 2x squared multiplied by another function like x squared plus 3x. In order to take the derivative of this, you can assume that 2x squared is simply u, and this is v. So you can say y prime is simply going to be the derivative of the first function, which is u prime, times v, plus v prime, which is the derivative of the second function, times by the original function you have, which is u. So y prime is simply going to be 4x times by x squared plus 3x, plus v prime, which is 2x plus 3, multiplied by u, which is 2x squared. And that's it. That would be the answer for such a scenario. Now, one of the nicer rules that you can kind of sort of solve the problems of derivation by is known as the quotient rule, and we can say that is rule number 9. In the quotient rule, we learned that if you have a function like y equals to u divided by another function v, we can simply take the derivative of such a scenario by taking the derivative of the first function, so u prime, multiplying it by v, and then subtracting it by the derivative of the function on the denominator, and then multiplying it by u, and then dividing it by the square root of whatever is on the denominator. So this is known as rule number 9, which is also known as the quotient rule. It comes in handy at many scenarios, so knowing it and kind of writing it down for yourself is very important. Now, let's go ahead and do a couple of examples based on the rules that we learned today. So let's say we're asked to find the derivative, specifically the first derivative. Later on, when we go on and learn a little bit more about derivatives, you'll see that we kind of have more than, the first derivative. We sometimes take two derivatives, and we call that the second derivative. If you take the derivative 3 times of a function, we call that the third derivative. But nonetheless, we're taking the first derivative, or finding the first derivative of the following functions. So for example, y equals to the square root of 4x squared minus 9x plus 1. Now you can go ahead and pause the video, try to solve this problem by yourself, and then you can try doing this one. Y equals to 2x plus 7 divided by 9x minus 6. All right. So let's go ahead and do the first one. The first one obviously uses the rule of square root's derivative. So y equals to the square root of u. You can take the derivative of such a function by simply taking the derivative of u, which is u prime, and then dividing it by 2 times radical u. So y prime in this scenario is going to be 8x minus 9 divided by 2 times the square root of 4x squared minus 9x plus 1. And that's about it. That's how you take the derivative of this function. Let's go ahead and take a look at the next one. Now this one is in the form of y equals to u over v. So we have to use the quotient rule for this one. Now be careful about this rule, because sometimes you can kind of get confused about it, but it's really simple. So you just have to take the derivative of the denominator, u prime times v, subtract it by the derivative of the denominator, which is v prime times u, divided by v squared. So y prime is simply going to be u prime, which is 2, multiplied by b, which is 9x minus 6. You know, this is obviously u and this is v, the function on the denominator, subtracted by the derivative of the denominator, which is 9, multiplied by 2x plus 7, divided by the 9x minus 6 squared. Basically, you take whatever's on the denominator and you raise it to the power of 2. So now we kind of have to simplify this, because as you can see, there are numbers that can expand with the brackets in front of them. So y prime is simply going to be multiplied 2 by 9x and by negative 6, and then negative 9 by 2x and by 7. So what you get is 2 times 9x, which is 18x, minus 12, minus 18x, minus 63, divided by 9x minus 6 raised to the power of 2. So you'll be left with the 18x's cancel out, and y prime is simply negative 63 minus 12, that's negative 75, divided by 9x minus 6 raised to the power of 2. All right, so one of the most important and key things about calculus is practice. So try to get as many examples as you can online, search about it, or look at your teacher's notes or the way you have examples in your book, and try to do as many examples as you can, because with more practice, the better you get at this and the better you understand the concepts behind the initial forms. So as you know, this is a couple of parts of video. This is not the complete video on calculus. I'm going to be uploading more on different rules, so stay tuned and make sure you subscribe. Take care and good luck.